In this video, we will talk about the basis of functions and their graphs. We're going to determine how to calculate the range and the domain of a relation, determine whether or not a relation is a function, determine whether an equation represents a function, evaluate a function, and graph functions by plotting points. We will also use the vertical line test to identify functions, obtain information about a function from its graph, identify the domain and range of a function from its graph, and identify intercepts from a function's graph. So first, let's talk about how to figure out the domain and range of a relation. A relation is any set of ordered pairs. The set of all the first components in the ordered pair is called the domain, and the set of the second component is called the range. So you have an ordered pair. Ordered pair is two numbers. The first number is your domain, that's your x value, and the y value is your range. So in this first example, we're going to determine the domain and range of the relation. So once again, the domain will be all of the x values in each one of these ordered pairs. So we have 0, 10, 20, 30, 40. Then we have the range, which would be all the y values. 9.1, 6.7, 10.7, 13.2, 21.2. Now we're going to determine whether or not a relation is a function. A function is a correspondence from the first set, called the domain, to the second set, called the range, such that each element in the domain corresponds to exactly one element in the range. So in order for this to be a function, an element in the domain cannot repeat itself. So if you have a bunch of ordered pairs and you see that some of the x values repeat, then this will not be a function. Okay? So if it does repeat, it is not a function. All right, so let's look at our first example. We have the order pairs 1, 2, 3, 4, 6, 5, 8, 5. So let's look at the domain. We're only going to look at the x values, and we're going to determine whether or not any of these x values repeat. So I have 1, 3, 6, 8. As you can see, none of these values repeat. So this is a function. No elements in the domain repeat. In this next example, we got negative 2, 3, negative 3, 5, negative 2, 5, negative 5, 7. Let's look at the domain. We have negative 2, negative 3, negative 2, negative 5. As you can see, the negative 2 repeats. That means that this is not a function. I have a U-try problem up here. You can try this on your own. The answer to this problem is not a function. Now we're going to determine whether or not an equation represents a function. If an equation is solved for y and more than one value of y can be obtained for a given value of x, then the equation does not define y as a function of x. So let's look at this first example. We have x squared plus y squared is equal to 1. We are going to get y by itself. I'm going to subtract x squared from both sides. I get y squared is equal to 1 minus x squared. To get y by itself, I need to take the square root of both sides. When I take the square root of the right side, I have to put my positive negative sign in front of this square root. So I end up with y is equal to positive negative 1 minus x squared. So since we have a plus minus here, this shows that for certain values of x, there will be two values for y. So that means that this is not a function. So when I say two values of y, let's say when I plug in a number for x, and let's say I calculated it and I got an answer of -8 and 8 because we got this plus minus sign in front. So that means it's going to give us two answers. In order for this to be a function, we should only get one answer for y when we plug in an answer for x. But in this case, we get two answers for y when we plug in for x. This next one, we have x plus y is equal to -3. We want to solve for y, so I'm going to subtract x from both sides. I get y is equal to -x minus 3. So when I plug in a value for x, let's say I plug in 1. When I plug in 1, y is going to be equal to -4. So any value that I plug in for x is going to give me one value for y. Any value I plug in for x will give me one value for y. So that means that this is a function. Okay, I have a U-try problem here. I'll go ahead and let you work it out. The answer is not a function. The next part, we're going to talk about how to evaluate a function. We have a special notation. When you see f with the x in parentheses, that is read f of x or f at x. It represents the value of the function at the number x. It does not mean f times x. So make sure you know that it does not mean f times x. So let's look at this problem. We have f of x is equal to x squared minus 2x plus 7. We want to evaluate this at -5. So we're going to calculate f of -5. This means whenever we see an x, we're going to substitute -5 in. And then we're going to calculate the answer. So -5 squared is 25. -2 times -5 is 10. And then plus 7. I get 42. The next one is f of x is equal to 2x squared minus 5x plus 1. We want to evaluate f of 3. Whenever I see an x, I'm going to plug in 3, and then I'll calculate this out. I end up with 2 times 9. 2 times 9 is 18. -5 times 3 is -15 plus 1. This gives me 4. So f of 3 is 4. I have a U-try problem here. You can calculate it out on your own. The answer is 23. So now we're going to look at graphs of a function. We're going to graph these functions by graphing their ordered pairs. So we're going to graph f of x is equal to 2x and g of x is equal to 2x minus 3. We're going to graph them on the same graph. We're going to start with x is -2 and we're going to end with x is 2. So f of x is also the same as saying y. So let me go back. F of x is the same as y. They also have different functions. You might see g of x. You might see h of x. Just know that all of these are equal to y. It's just your y value. So if we look at this first graph, we're going to do a ordered pairs here. So the first graph I'm going to do is x, f of x. Okay, so don't forget f of x is equal to 2x. So we're going to start with -2 and we're going to go to 2. So we're going to have -2, -1, 0, 1, 2. So I just do a table of values. So I know when I plug in -2 back in for x, 2 times -2 is -4. When I plug in -1 back into this function, 2 times -1 is -2. Then I plug in 0, 2 times 0 is 0. When I plug in 1, 2 times 1 is 2. And lastly, 2 times 2 will give me 4. So I have my ordered pairs, and I'm going to go ahead and graph these. First point will be -2, -4. I have a point here. -1, -2 will be a point here. 0, 0 is at the origin. 1, 2 will be a point here, and then 2, 4 will be a point here. And then we can go ahead and draw our line through the points. Let's see if I have a line function. Okay, let's see. Alright, so if I put this, hold on, I'm going to change it over here, and then I'm going to turn it. Oop, that didn't work. Okay, hold on. There we go. So let me move it down this way, and then turn it this way. I would draw this freehand, but I'm not very good at drawing lines freehand. So there you go. That's the line of the function. So now, let's go ahead and graph g of x. Remember, g of x is equal to 2x minus 3. So I'm going to do my table of values. So we already know what 2x is equal to when we plug in these numbers. All we have to do now is subtract 3. So if we plug in -2 in here and we subtract 3, that'll be -4 minus 3, which is -7. Once I do -1, we know that's 2 times -1 is -2. Subtract 3, we get -5. When I plug in 0, I'll get -3. When I plug in 1, I get -1. And when I plug in 2, I get 1. So we're going to go ahead and graph these. So we got -2, -7, which will be a point here. -1, -5 will be a point here. 0, -3 is here. 1, -1 will be here. And then 2, 1 will be here. So I'll go ahead and draw my line. Pick this one again. See, put it right here. And then I'm going to turn it this way. Alright, so as you can see, there we go. I got both of my lines on this graph. So what's the difference between these graphs? The graph of g of x is almost the same as the graph of f of x, except it's shifted down 3 units. Okay? So if you start from any one of these points, let's say I start here, and I go down 3, 1, 2, 3, I'll hit the other graph. So g of x is the graph of f of x shifted down 3 units. Next, we're going to use the vertical line test to identify functions. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So I'm going to just randomly draw a graph. So let's say I draw this graph here. Like I said, I'm not the best at drawing. And I wanted to do a vertical line test. So I am going to draw a vertical line on this graph, anywhere on this graph. So let's say I draw a vertical line here. As you can see, it hits the graph once. Let's say I draw a vertical line here. It hits the graph once. If I draw the vertical line here, it hits the graph once. So as long as the vertical line test hits the graph once, then this graph is considered a function. If the vertical line hits the graph more than once, then it's not a function. So in this case, the vertical line hits the graph once. Let's do another one. Let's say I have this graph here. And I wanted to do a vertical line test. So let's say I drew a vertical line over here. It hits the graph once. But let's say I draw a vertical line here. It hits the graph more than once. It hits it here, here, and here. So that means that this is not a function because I hit the graph more than once. So vertical line touches the graph more than once. Okay. Next, we're going to look at a graph and get information from it. So in this particular problem, it talks about T cell count and HIV infection. If you don't have HIV, your T cell count should be very high. Okay, so as you can see on this graph, we have the time after infection of you getting HIV, and then your average T cell count. So let's say you're not infected with HIV. Your T cell count on average should be close to 1,200 milliliters. I think that's how they graph it. Is it milliliters? Yes, milliliters of blood. All right, per milliliters of blood. So in this part, you're asymptomatic. So if you look at this graph, the red part, so for the first 3 years, you don't have any symptoms of HIV. So after 3 years or so, you're going to start getting symptoms. You're in the symptomatic stage. And as time goes on, as the years pass on, your symptoms get worse until eventually you get diagnosed with AIDS. Okay, but right now with today's medicine, they know you can live with HIV and likely not get AIDS. So as you can see, once about, what year is this? Around 8 years, you're diagnosed with AIDS. So we're going to look at this graph and we're going to figure out some information. We're going to calculate F of 5. So F of 5, they want us to know what is your T cell count after 5 years of being affected with HIV. Okay, so we're going to look at the graph, and to calculate that, we'll go to 5. We're going to go up to the graph and then across to see what this value is, and I get 400. So after 5 years of being affected with HIV, my T cell count should be 400 milliliters. Okay. Next, we're going to calculate F of X equal to 100. Basically, we got to figure out the X value that corresponds to 100. So 100 is going to be on the y-axis. So let's say this is 100 here. We're going to go across until we hit the graph, and then we go down. So in this case, X is 9. So basically, this is asking us, when your T cell count is 100, how many years have you been affected with the HIV virus? So in this case, it would be around 9 years. In this next problem, we're going to look at some more graphs, and we're going to look at their functions. So the first one says F of X is equal to negative 2.7x plus 275. And G of X is equal to 0.01x squared minus 4.7x plus 360. And this models the chance as a percent that a 60-year-old will survive to age X. The bar graph shows the chances of a 60-year-old surviving to various stages. So if you look at this graph, this is a 60-year-old. There's an 87% chance that they live to be 70. There's a 61% chance that they live to be 80, and there's a 2.7% chance that they live to be 100. We're going to find and interpret f of 70. So we're going to use the actual function. So this graph gives us the actual numbers, but we have functions that were derived. So we're going to calculate f of 70. So if we go back to the function, every time we see an x, we're going to plug in 70. So make sure you plug it into the right function because we also have a g of x. This one asks us for f of x. So when I calculate this, I get 86. So the chance of a 60-year-old surviving to age 70 is 86%. Now let's calculate g of 70. So this time we're going to look at the g function and we're going to plug in 70 whenever I see an x. And when I calculate this out, I get 80. So this means the chance of a 60-year-old surviving to age 70 is 80%. So the actual data is in this table, in this graph actually. So now let's figure out which model is the better one. So based off our graph, the chance of 60-year-old surviving to 70 is 87%. My f of x function gives me 86%. So that means f of x is closer to 87% than g of x. G of x gave me 80%. So I'll write this out. So based off the graph, and this is a bar graph, the chance of a 60-year-old surviving to 70 is 87%. So our function f of x is closer to 87% than g of x. So don't forget, f of x gave me 86%, whereas g of x gave me 80%. So the f of x model is closer to the actual data. In this next example, it says the bar graph shows the wage gap between men and women for selected years from 1980 through 2010. The function g of x is equal to negative 0.01 x squared plus x plus 65 models the wage gap as a percent x years after 1980. And the graph of the function g is shown below. We're going to calculate and interpret g of 20. So g of 20, that means x is equal to 20. And that is 20 years after 1980. So that would mean the year 2000. That's the year 2000. So when we calculate g of 20, I'm going to plug everything back in. I get 81. So what does this mean? So this is g of 20 is equal to 81. So this represents a wage gap of 81% in year 2000. The next question says, does g of 20 overestimate or underestimate the actual data? The actual data is shown in this bar graph. So if we look at the year 2000, it's telling us 80%. We calculated 81%. So g of 20 overestimated because we got a higher value. We got 81%. It's not that far off, but it overestimated by 1%. because we calculated 81%. The bar graph gave us 80%. So if you subtract, that's how I got the 1%. The next part talks about how to identify the domain and range from a graph. To find the domain of a function from the graph, we look at all the inputs on the x-axis that correspond to points on the graph. And to find the range, we look at all the outputs, and that will be on the y-axis that correspond to the points on the graph. So if you look at this first graph, I'm just going to look at the endpoints. So I'm going to look at this point here, that's negative 2, 0, and then I'm going to look at this point here, which is 1, 3. When you do these graphs, if you have closed circles, we're going to use brackets when we write it out in interval notations. If you have open circles, we're going to use parentheses. So in this case, I'm just looking at the endpoints. My domain would be negative 2 and 1. Negative 2 and 1. So when we write this, this is our domain. When we write this, since we have closed circles, it's going to be in brackets. So it goes from negative 2, 1, and we'll use brackets. The range will be the y values. Once again, since we have closed circles, we're going to write it in interval notation, and we're going to use brackets. And this next one, as you can see, we have a closed circle and an open circle. This point here is negative 2, 2, and this point here is 1, negative 1. So since we have an open circle, when we write this in interval notation, we are going to use parentheses. So we got the point negative 2, 2, and we got the point 1, negative 1. The domain, remember, will just be your x values. So when we write it in interval notation, we have a open circle. Sorry, so we're going to use a parentheses here for negative 2, and this 1 over here is closed circle, so we're going to put 1 and a bracket. My range will be the y values, and so when we write it in interval notation, we're going to write it with a bracket. We always start with the smaller number, so it's going to be negative 1. Negative 1 has a closed circle here, and then it's going to go up to 2. 2 has an open circle, so it's going to be a parentheses. In this next one, we have a parabola, and we don't have any circles on this one, but the domain is how your graph goes along the x-axis. So as you can see, this graph has an arrow. So that means this graph is going to keep going out, 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 out. And it's going to keep going along the x-axis. So if I were to keep drawing this, it goes out, out, out. Same over here, out, out, out. So the domain, which will be along the x-axis, will be from negative infinity to infinity. You always put parentheses on infinities. Your domain is how your graph acts along the y. So my graph starts here and then it goes out. Okay, so my range would start from 0, and I'm going to put a bracket on it because 0 is included, and it's going to keep going out into infinity. So we're going to put an infinity on here, and we're going to put a parentheses. This is a U-try problem, and these circles should be actually colored in. I'll go ahead and give you the answers. The domain will be from negative 3, 4 with brackets, and then my range will be from 0 to 5 with brackets. So these should be closed circles. These should not have arrows. We have arrows on there, that means it keeps going. Since we have circles, that means the graph stops there. The last part talks about how to identify intercepts from a function's graph. To figure out the x-intercepts, you look at the points where the graph crosses the x-axis. The y-intercepts are where the graph crosses the y-axis. A function can have more than one x-intercept, but at most one y-intercept. So let's look at this graph, and I denoted the where the graph hits the x-axis in red. So this will be your x-intercepts. When you write x-intercepts, it's written as a number and 0, and for the y-intercept is written as 0 and a number. So if we look at this graph has an x-intercept at -3, 0, -1, 0, and 2, 0. When we look at the y-intercepts, the y-intercept is where the graph crosses the y-axis, which will be here, is in blue. That point would be 0, -6. I have a U-try problem here. I'll go ahead and write out the answers for you. The x-intercept will be at the point 3, 0, and the y-intercept will be at the point 0, 6.